This meeting is being recorded.
Problem 2 is very similar to problem 1. It asks us to draw a Lewis structure for each of these compounds listed below. So let's take a look at compound A here and see if we can do that. So just like in problem 1, we're going to start with drawing the carbon chain and any atoms that are bonded to that carbon chain. So this is what we're given, our condensed molecular formula, and let's transcribe this. So we see HOC, and then that carbon has 2 hydrogens attached. This next carbon, the same thing, another 2 hydrogens, and we continue here, right? So we have 3 CH2s in a row, and then what do we see? We see C, and then H, and then O. So you may be tempted to try this, but what you might notice is that hydrogen would then have 2 bonds, and we know that that cannot happen. So like before, when we have hydrogens right next to carbons, we know that that's directly bonded to the carbon, but we have to assume that this carbon is also directly bonded to the oxygen, just like we assume that it's bonded to this carbon, like up here, right? How we skip over the hydrogens and know that it's bonded to the next carbon. So the real structure would look more like this, where we would have the carbon bonded to an oxygen and a hydrogen. Right, so this would be our first step in drawing the hydrocarbon chain and any other atoms, such as the oxygens. So now we look for if every atom has a full octet. So we would look for 4 bonds on all the carbons. To have neutral oxygens, we're going to have 2 bonds and 2 lone pairs, and then every hydrogen 1 bond. So everything looks good, except for this 1 carbon on the end. The carbon bonded to the oxygen over here on the right, there's only 3 bonds. So we're going to assume that there's a double bond between our carbon and oxygen here to form this carbonyl, right? So we're going to add a pi bond here. And we also want to add 2 lone pairs of electrons on this oxygen. And then this oxygen over here on the left already has the 2 bonds, so we just need to add 2 lone pair electrons. So this is our Lewis structure for compound A. So let's take a look at compound B next. So we'll draw a dividing line here. So we have compound B. So our first atom is 3 chlorine. So again, you could be tempted to just kind of go right through, but what you hopefully notice is that chlorine cannot form more than 1 bond. It is monovalent. So each of those chlorines are actually bonded to this first carbon. So we would see something like this, right, with these 3 chlorines, and then let's continue through. So that carbon's bonded to another carbon, and then we see here we have 2 oxygens. So again, you might be tempted to just go through and do 2 oxygens bonded to each other like this. But what we notice is that this carbon only has 2 bonds. So we would actually, when we see this O2 designation, we should actually think that one of the oxygens will be in a carbonyl, and then our next oxygen will be bonded to the carbon also like this. So instead of an oxygen-oxygen bond, we have 2 carbon-oxygen bonds, and then we have our hydrogen on the end like this. So if we bonded our carbon with a single bond, we would go back and make sure that the carbon has a full octet and add that pi bond again over here. So the last thing we need to check for would be lone pairs to complete our octet. and those would be on both of the oxygens. And then the chlorines, right, they would have 6 valence electrons that we need to fill in, so 3 lone pairs that are missing. And this would be our Lewis structure for molecule B.